Hello, this is Akshay with another video here, and this video is going to focus on our numerical problem. As I have told you before, that is numerical problem is a way to test what you have learnt in the form of concepts. So let us try to solve this very numerical problem, and just at the same time just to check whether we have understood what we have learnt in the previous classes there. So here it is a numerical problem, and let us go through the statement. An electric lamp of 100 ohm resistance, a toaster of resistance 50 ohm, and a water filter of 500 ohm are connected in parallel to a 220 volt source. So these are the three, you can say, electrical appliances given over here which are connected to 220 volt source. Just to simplify the thing, I have created a circuit diagram for these three resistors here. An electric lamp of 100 ohm, here it is electric lamp having resistance R1 is equal to 100 ohm. Thereafter a toaster of 50 ohm resistance, it is a toaster R2 having resistance equivalent to 50 ohm. And then it is a water filter of 500 ohm, here it is R3 that is having resistance equal to 500 ohm. It is electric lamp, it is a toaster, and it is a water filter are connected in parallel. So we are going to create a parallel combination, and you know by the definition of parallel combination, one end of each resistor is going to connect it to one common point. Here it is, it goes this way, here it is one common point, and the remaining one end of those resistors going to be connected to the another common point, and just creating a kind of a parallel configuration here. So this is a parallel combination and connected. Thereafter what is being written here, in parallel to a 220 volt source, means they are connected in parallel and then connected to the 220 volt source. So the 220 volt source is the potential difference applicable to the combination of these three resistors in parallel. So let us have a connecting bias here, taking them over here to the two different terminals of the battery, and that makes a complete circuit diagram. Here it is. Now next start here, the remaining part of the statement will take you to the problem. It is gonna ask here, that is, yes, what is the resistance of an electric iron? Means now it is the fourth resistor. One, it was electric lamp, second it is toaster, and the third one water filter, and now it is electric iron. So this is the fourth you can say that is electric appliance which has come over here. So what is the resistance of an electric iron? I have taken another mini circuit diagram for electric iron. There you are, it is electric iron, and resistance has been asked that what's gonna be the resistance of electric iron, and I have taken it as R4, and R4 going for question mark, that is R4 is the resistance of electric iron. That's what it is being asked here, that is what is the resistance of an electric iron connected to the same source. An electric iron which is connected to the same which is connected to the same source means, the same source means what was the source earlier used, the same source is gonna be used in with respect to electric iron. Source means that is potential difference. The same source means it was earlier 220 volt, same it is gonna be over here in the case of electric iron. And what we have done over here, just taking the connecting wire and connected the two terminals of this very resistance, that is electric iron, to the two different terminals of the battery. One is positive and another one is negative, and the same source means this very electric iron will get the same voltage that is being obtained or received by these three resistors, that is 220 volt. There you are, it is V is equal to 220 volt. R4 we are going to find out, but still we are left with a part of an important part of this very numerical problem. Let us start over here. That means electric iron, you need to find out the resistance of electric iron which is connected to the same source. I have told you same source, here it is 220 volt. That means electric iron takes as much current, that's important, it takes as much current as all the three appliances means the current taken by electric iron will be equal to the current taken by all the three appliances, means the same current will flow through electric iron, the same current which has just traveled through the combination taken in parallel. What does it mean? It means if you are knowing that what is the total current flowing through the combination, we are gonna use that very total current in the case of electric iron, as it is being mentioned in this very numerical problem, that electric iron will take as much current as all three appliances collectively taking. So firstly we are going to find out that the total current being received by the combination over here, that is the I, current flowing in the circuit, that is current I. Once we know the current I, according to this very statement, the same current which is taken by these three appliances together will travel through the electric iron, and it means it is I current. Here you are, that is, this is the I, this is the I. So once you know the total current flowing through this very combination, we will say that is the same current. According to the given statement, the same total current will flow through the electric iron. So it's quite easy right now. By using Ohm's law, we can just crack this part of the numerical problem. That is, you know V, and you are going to find out I over here. Once you know I, you can find out R4 by using Ohm's law triangular technique. So firstly, our job is to find out I here, that is the total current. So this circuit diagram is meant to deliver the total current I here. Once we got I from this very circuit diagram, we would be in a position to use that very I in the case of electric iron, as it has been suggested by this numerical problem. That is, yes, I current will flow through R4. So here I, we have just gonna have over here, and then we will use the value of I, use the value of V, and then we will find out the resistance of electric iron. So that's how we will have to proceed in the forward direction. So let us put this everything in the mathematical form here. An electric lamp of resistance 100 ohm here, resistance of an electric lamp, whatever it is given, we will write over here electric lamp comma R1, and it is 100 ohm, that is being given. A toaster of resistance 50 ohm, another one, resistance of a toaster, it is R2 and it is 50 ohm, and a water filter of 500 ohm resistance. So resistance of a water filter, it is R3 and it is 500 ohm, are connected in parallel. I have just mentioned over here, connected in parallel to a 220 volt source. It means the potential difference V, it is equal to 220 volt. Okay, next, what is the resistance of an electric iron? It means the resistance of electric iron has been asked here. So here it is, resistance of an electric iron, resistance of an electric iron, it is being considered as R4 and going for question mark. Okay, what is the resistance of an electric iron connected to the same source? It means the potential difference obtained or received by electric iron is equal to 220 volt source. So here it is, potential difference obtained by an electric iron it is V, the same. That's why I am taking it V, the same, and it is remain the same, means 220 volt. Here it is, V is equal to 220 volt source. That takes as much current that I have told you before. That means the electric heater, electric iron will take as much current as all three appliances. But does this mean that is electric iron will get the same current as the current being obtained or received by these three appliances together? So here we will write here, that is the current obtained by an electric iron is equal to the total current obtained by the three appliances together. Here it is. Or current obtained by an electric iron, current obtained by an electric iron is equal to the total current obtained by the three appliances. And total current we have taken over here, it is I. Here it is I, where I is equal to the total current being received by these three appliances together. So it means we have got everything over there. Next is, what is the current through it? Means how much current flows through that very electric iron. So here another part is current flows through an electric iron, and how much it would be? Very simple. This is I. I is the current going to flow through the electric iron, and here it is I. So all we have got here, but is being contained in this very statement here. Now the time has come to just firstly find out the I and then find out the resistance, and then we will say that is whatever the current has traveled through these three resistors together will flow through the electric iron, and that's gonna be the current flowing through electric iron, that is I, and the resistance we can get by using Ohm's law there. So all these things we have put up here. Now we are gonna use the previous concept to just find out the current I. There are two ways to just crack this very numerical problem. One is by finding out the total resistance over here. That is, the total resistance in parallel combination is the reciprocal of the resultant resistance. Here it is, reciprocal of resultant resistance is equal to the sum of reciprocals of individual resistances, 1 upon R1 and 1 upon R3. Here it is. That's the one way. Once you know the total resistance of this very combination, you know the total voltage. Total resistance is known to us. Total voltage we are knowing here. We can find out the total current here. This is the total current. Here it is. We can find out the total current. This one. Total current I will be there. That's the one way. Now the second way is that as we have understood in the case of parallel combination, that in parallel combination the total current got distributed among the number of resistors. It means there are three resistors. It means this very total current I coming from the main supply line will get distributed among these three resistors here, and we will say that is, let I1 current is flowing through R1, I2 current is flowing through R2, and I3 current is flowing through R3. So what we are gonna do, firstly we are going to find out I1, then we are going to find out I2, and thereafter we are going to find I3. Once we know these values I1, I2, I3, then we will write that in parallel combination The total current is always equal to the sum of the current flowing through individual resistances. Means I is equal to I1 plus I2 plus I3, and we will get the total current, and that total current I would be taken over here to find out R4. That's how we are gonna just reach the destination. So let us start firstly by finding out the I1 and then I2 and then I3. I'm going to wipe it away here so that you can get a clear cut understanding what I'm gonna do here. So here, so here it is. Let us find out I1. To find I1, and you know I1, we are going to use this very technique, Ohm's law triangular technique, VIR. It means we want to find I or I1. It means it's gonna be V upon R. Here it is. I1 is equal to, what is V? This is going to the formula, total voltage, that is V, and I1 is the current flowing through R1 resistor, V upon R1, or I1 is equal to V, it is 220 volt, and R1 it is 100 ohm, and therefore current I1, it is flowing through R1, is equal to 2.2 ampere. That's the first part. So we have got I1 here. So we are gonna remove these things and just keeping it over here for further use down the road. That is, we have got here, yes, I1 is equal to 2.2 ampere. Now time has come to find out I2. Here it is. Now we are going to find out I2. Same triangular technique you have to keep in mind. Here it is, I2, and in order to find out I2, what the formula going to be used here? According to Ohm's law, I is equal to V upon R. It is V, but R is R2. I2 current flowing through R2. So here resistance is going to R2, or I2 is equal to voltage 220 volt. All these resistors will get the same voltage. You have learnt it in parallel combination. That is, yes, one common point is connected to the positive terminal of the battery, and another common point is connected to the negative terminal of the battery. It means by means of common point, each and every you can say that is end of these conductors are going to gonna have a connection with the two terminals of the battery, and that's why they are going to get the voltage as that of the main supply line. It means 220 volt is gonna be received by R1, same voltage is gonna received by R2, and the same voltage is going to be received by R3, thanks to the parallel combination they are in. So 220 volt divided by R2 is 50 ohm. So here it is, and therefore I2, that is the current flowing through resistor R2, is equal to 4.4 ampere, and we are gonna write it here, that is I2 is equal to 4.4 ampere. Now time has come to find out R3. Here it is, time has come to find out I3, and the same technique, here it is, I is equal to V upon R. Therefore, I3, by using Ohm's law, I3 is equal to V upon I3 current flowing through R3. Here it is, R3, or I3 is equal to V, it is 220 volt, and R3, how much it is? 500 ohm. So it goes this way, and it comes, therefore I3 current is equal to, when you are going to solve it, it comes out to be 0.44 ampere, and this is I3, and it is equal to 0.44 ampere. So there you are right. Now we have got all these individual currents, I1 flowing through R1, I2 flowing through R2, I3 flowing through R3. And we have learnt, since this is a parallel combination, and in parallel combination, that's what we have learnt. In parallel combination, that's the total current is always equal to the sum of the currents flowing through individual resistances. It means the current I, which has got distributed in the form of I1, I2, I3. Okay, so when we are gonna add these I1, I2, I3, it comes out to be I. That is total current I is equal to I1 plus I2 plus I3. So according to the parallel combination, the total current, yes, total current I flowing in a circuit is always equal to the sum of currents flowing through individual resistances, and the sum of currents means I is equal to I1 plus I2 plus I3, and that is what we have learnt in parallel combination. That is, the total current flowing through the circuit is equal to the sum of the currents flowing through individual resistances. So I is equal to I1, it is 2.2 ampere, plus I2, it is 4.4 ampere, and plus I3, it is 0.44 ampere. Let us add them together, and therefore total current flowing through the combination of these three resistors I, and it comes out to be 7.04 ampere. Here it is. So I current we have got, and it is 7.04 ampere. This is, so there you are right now. We have got I. So once we got the I, we will proceed to the next problem here. And the problem is that I we have got, and it is 7.04 ampere. It has been mentioned in the statement I have just tabulated a bit earlier. That is, that whatever the current flowing through these three resistors together, that current will flow through the electric iron. So here we will write that according to the given statement, the total current I, which has just collectively go through the combination of these three resistors, that is I, will flow through this very electric iron. So it means I is equal to 7.04 ampere. So it means 7.04 ampere current will flow through the electric iron. So we know the voltage the electric iron is subjected to. A, B, we know the amount of current flowing through the electric iron. It means we are knowing both the physical quantity V and I. We can find out what is the resistance of electric iron. So here we know the current flowing through electric iron. Current flowing through electric iron is equal to I is equal to 7.04 ampere. This is the current flowing through the electric iron. And the resistance of the electric iron we have to find out. The voltage potential difference the electric iron is subjected to is 220 volt, and the resistance of the electric iron, it has been taken as R4 going for question mark. Once again the triangular technique will come into play. It is V, it is I, and it is R, and we know we want to find out R4. It means R is here, it is gonna be V upon I. So by using Ohm's law, we will write down R4 is equal to V upon I, or R4 is equal to how much V is 220 volt, and how much I is 7.04 ampere. Now we are gonna solve it. Or R4, that is the resistance of electric iron. Here it is 220 volt multiplied by, divided by 704. We are gonna remove this very decimal here, and it is gonna be 100. And let us solve it. Eleven, 6, and it's 4, and it is 20, and it is 16, and it is 5, and it is 4, and it is 25. Or R4 is equal to 125 divided by 4, and remember it is ampere here. and volt upon ampere is always equal to resistance. So therefore resistance of electric iron, comma, it is R4 is equal to 125 divided by 4, and it comes out to be 31.25 ohm. That is the resistance of electric iron. R4 is equal to 31.25 ohm. That's one part. And second, what is the current through it? Means what's the current flowing through electric iron? Here it is, we have already got it, because it was mentioned in the statement the current flowing through electric iron is always equal to the total current flowing through this very combination, and total current I we have calculated 7.04 ampere. It means this very current will flow through electric iron. And another, therefore current flows through electric iron, and it is I, that was the total current I, and it is 7.04 ampere. So there you are. That's how you are gonna take on such kind of a numerical problem involving or revolving around the conceptual clarity. If your concepts are absolutely spot on, then you can crack these numericals without any single mistake there. And that's how to proceed as far as the numerical problems are concerned. So that's it here for this very numerical problem.